So notice how both of the ends of the graph go in the same direction. Okay, so this is a continuation of the day one notes. We just defined even degree, and we are giving examples of a positive and negative leading coefficient, what that would look like. What do you think the negative leading coefficient, the graph of that, what would that look like? In what way? It would be going down. For odd degree, the definition, ends are going in the opposite directions. Yes. Examples of what the graph would look like. Notice how the ends are going in opposite directions. What would be different about a negative leading coefficient? Rather than pointing up, it would point down. Yeah. When they're not in the opposite direction.
Like one is going down, and the other side is going to the right. It's not the opposite. What are the only directions that exist when you talk about vertical movement? Logically. Up or down? That's it. So it either is up or down. If you incorporate left and right, that's a whole different direction. Only up and down.
All right, does everybody have the notes? Okay, we're going to move on. Now we're going to be looking at this polynomial, and we're going to first write it in standard form. What does it mean? Crystal, what does it mean for a polynomial to be in standard form? What does it mean? On the front of this page, you have a definition of standard form, so it may be helpful to look at that. Highest, lowest of the exponents. So the exponents have to go in order from highest to lowest. So what's going to go first? To the fourth. -1. Good. Notice how the exponents are going order from greatest to least. What is our degree? 4. Why is it 4? Because it's our highest exponent, our greatest exponent. What is the name of this polynomial? It could be helpful to have your flashcards out so you can refer back to them. What is it? Close. Quartic. Quadratic, it would be if the degree was 2. The largest degree was 2. Our leading coefficient? -2. Constant term? What's a constant term? It's a term with no variable. So it would be -1. Good. And a graph, you have these from your note cards, would look something like that. What? Okay, good. Good. Do you want to do the next one? How do I write this in standard form? So tell me. Yep. Next.
I'm at 4, negative 4, x squared, right?
Yep.
Plus,
Yeah.
so plus 7.
Yeah. Perfect. What's our degree? 3. What's the name of a polynomial with degree 3? Cubic. Our leading coefficient is 8. What's our constant term? 0. Because all of these terms have a variable attached to it, so our constant is 0. And a graph of it, like you have on your flashcards, would look something like that. Are we ready to move on? Yep. I'll go like this. Okay, let's do the next one. What is this in standard form? Perfect. Degree. Name. Is 1, good. 0. Okay, last one. Standard form, how do I write it? Yeah.
So for graph, does it depend on the name?
Yeah, and the name depends on the degree. So whatever your highest degree is going to represent what the graph will look like. F of x equals, good. What's our degree here? What really would go here if I were to write it in? 1. Name? Linear. Leading coefficient? Yes. Constant? -2. And a graph of this. Does anybody have any questions on any of these 4? Yeah.
So, for number 4,
Yep.
for the graph, could it be like this way or does it have?
Linear in general means it's a straight line like that, but because the slope in this one is negative, because it's a negative x, which means our slope is -1, it's going to go down, decreasing. Does that make sense? Okay, we're going to move on. What does operation mean? What is an operation? What's an operation? Anyone? What's an operation? What does that mean? in math? Okay. PEMDAS is a good hint. So, what does PEMDAS stand for? Yep. Mhm.
Then you got multiplication, division, and then subtract.
Good. So which of those are operations? Out of what he just said, what PEMDAS stands for, which of those are operations?
So you would start with the parentheses first. It will start from left to right.
But parentheses isn't an operation. Yep, perfect. Multiplication, division, addition, and subtraction are all operations. For this worksheet, we're going to be mainly doing multiplication, addition, and subtraction. Okay? So let's start with the first one. What is this? Does anything change in this? What does this plus sign represent? But what is really there? So what do you do when you have two parentheses added together to get rid of the parentheses? Distribute. What am I distributing here to this parenthesis? 1. Does anything change when I multiply every term by a positive 1? No. So let's rewrite this. Without the parentheses. Okay, so now I want to write this in standard form. What do I have to do? Put what in order? From greatest to least with respect to exponents. So what am I going to start with? 5. So we're going to look at all the terms with an exponent of 5. So when we have x to the 5th and negative x to the 5th, what does that come out to when we combine them? Negative 5x to the 5th. And something that's helpful to do, since we already did all the terms with exponent 5, is to just cross them out, because we're done with them. Next, what are we going to do? So you combined negative 4x to the 4th and x to the 4th, right? And he got negative 3x to the 4th. Cross them out. We're done with them. Next. Right. There's nothing else in here that has a degree of 2. What's next? Negative 11x. Done with that. And lastly, which is minus 5. And that is in standard form. All our exponents are going from greatest to least. Okay. What about this one? What are we distributing? Negative. What does this minus sign really mean? We said this is really a positive 1 that we're distributing. So what are we distributing in this one? A negative 1. So we're going to distribute it to every single term. Does anything change in this first parentheses? No. Okay, so what does this change to? When we do negative 1 times 15x. Negative 15x. Next. Positive 3. Plus 2x cubed. All right, and now we're going to combine like terms. What am I going to start with? Everything with a exponent of 4. So we have negative x to the 4th and negative 9x to the 4th. So what is that going to become? Negative 10x to the 4th. We have a negative x to the 4th and a negative 9x to the 4th. We're adding them together. What's negative 1 plus negative 9?
Wait, so then why would you like do that if 10x would have a 4?
What do you mean? So for this, all we were doing was combining this term and this term.
Oh, okay.
I think you were looking at this. Yeah, that's separate. Okay, what's next? Which becomes? Perfect. And next? Which becomes negative 5x. And last, plus 3. I'll leave this up a little. What about this one? How are we going to do this one? By distributing each term? Is that what you're saying?
Yeah.
Okay, so what am I going to multiply first? Which becomes? Just 15x? Squared. What am I multiplying next? Which becomes 20x. And next? Which becomes minus 6x. And lastly, minus 2 times 4, which is minus 8. It is. I'll fix it. Is this completely simplified? What do we have to do last? Combine like terms. So I'm combining. Good, and that becomes 14x. You could drop down the minus 8. Tim, you're going to do the next one with us. What's the first thing we're going to do? Which starts with a D? Distribute. So first we're going to distribute what? This to the x squared, to the 3x, and to the minus 4. So what's x? X cubed. What's x times x squared is x cubed. X times 3x is what? X times 3x? 3x squared. And last, x times negative 4. Are we done? No. Sure. Good. X times 3x, that becomes 3x? 3x squared. Good. Are we done?
No.
What do we have left? Good. To every single term. So what's our first one? And then we have you tell me. Negative 27x And last,
Plus 36.
plus 36. Okay, so now we have to put it in standard form. How am I going to write it? Good, so she combine. No, we're combine. What do you want to combine? X to the third, there's no other terms with a degree of 3, so we could just put it down. And now we're going to do what?
3 x or 3 x to the second power, right?
Yep, and we're going to combine with what?
Plus 9 x. Negative 9.
Which is why it's going to be negative 6x squared. All right, next.
Negative 4x to the 20, negative 4.
We're going to combine those, which becomes negative 31x. And lastly, plus 36. Does anyone have any questions this far? Okay. How am I going to write this one? How am I going to start this? X minus 6 squared.
Oh, you put x minus 6 and then another x minus 6.
Right, because this means the exact same thing, but this makes it easier for us to write it out in standard form. What am I going to do? Yeah. You want to come up here? What's the first step? Let me combine those two. What are we multiplying first? Which one? This one? Oh, I just wrote that. I don't know why. X squared. We're going to multiply these two first. Next. Good. Did everyone get that? Yep, because it's negative 6 times negative 6. And we have to simplify this. So I agree, this will become negative 12x. Is it in standard form?
Yeah.
So we're done. Okay, last one. We distribute the 4x squared to
2x.
yes. We distribute it to every single term in the parentheses. So what's our first term?
2x.
We have 4x, ax, and what's the exponent going to be?
No.
What happens when we multiply two terms with different exponents? We add them. So 7. Next, 4x squared times negative 10x cubed. To the 5th, good. And last, 12x squared. Is it in standard form? Yes. So we're done. Okay. Listen up. The next 2 pages are your homework for tonight. They exactly align with the notes that we just took.
Wait.
And the notes will be posted on Google Classroom and YouTube, okay? No, we're not done. We're going to continue taking notes. But for right now, so you know, these next 2 pages of 6.1 Day 1 homework are your homework for tonight. Okay? Next, I want you to open up to 6.1 Day 2 refresher. Quadratic functions. Okay, so we're going to take notes on quadratic equations. So I'm going to give you the 3 methods of solving a quadratic equation. So I want you to copy those down. The first method is solving by square roots. The second one is the quadratic formula. And the last one is factoring. For right now, we're going to be doing examples with solving by square roots. When you solve by square roots, so when you do this, you do it when there is no b term. This means, so at the top of your page, you see a polynomial in standard form. So it looks like this. When there's no b term, it doesn't have this in it. No.
So it has x, but it has the x squared term, not the middle x term.
Yeah. So this whole part is crossed out. How? There's 2 steps. First, isolate the squared variable term What does isolate mean? I'm sorry, what does it mean? Yes. Second step is isolate means get it by itself. Oh. Isolate means get it by itself. The second step, take the square root of both sides of the equation. Okay, so now we're going to use these notes to solve these questions. The first one, x squared equals 81. Our first step says to isolate the squared variable term. Is it isolated? Yes. So we can skip that step and go to the next one. Take the square root of both sides of the equation. So what am I going to do? Square root, both sides. And you're left with what? What do you have to also write here? Plus or minus y? Good. Did everyone hear Maya? Why you have to write plus or minus 9? Because positive 9 times positive 9 is 81, and negative 9 and negative 9 times negative 9 is also 81. So both solve the equation. Okay, number 2. 3z squared equals 18. What's the first thing I'm going to do? By doing what? Dividing by 3 to both sides. So you're left with z squared equals 6. Next step. What do I do? Square root of both sides. And you're left with, is 6 a perfect square? No. So you could either leave it as z equals plus or minus square root of 6, or you can find the exact decimal. So everyone take out your calculators and tell me what the square root of 6 is. Take out your calculators, guys. I want everyone to do it. I won't. So nobody say it out loud. I want everyone to figure it out, and then we can write it down. You do. Okay, so what did we get?
2.449.
Yep.
It's actually 2.4.
Okay, so we're going to always round to 3 decimal places. So you can stop at 2.449. Okay, so those are our 2 answers. Those mean the same thing. When you simplify square root of 6 further, it comes out to 2.449. Okay. Yeah? Okay. Okay. Let's do the next one. Negative 4w squared equals negative 305. Great. So what am I going to do? Divide both sides by negative 4, and we get what? W squared equals, everyone do negative 305 divided by negative 4. Just tell me what you get. Okay. Next, what are we going to do? We're going to do the square root of both sides. So we're left with What's the square root of 76.25? Plus or minus?
One person has it, we need more than one.
Did everyone get it?
Yeah.
We're doing the square root of 76.25 right now. Okay, what did we get? 8.732. Raise your hand if you got that answer. Good. Okay, number 4. Number 4, what am I going to do? Subtract 6. What am I left with? Okay, what's our next step? Square root. Can you do the square root of a negative number? No. So in the future, you'll learn that taking the square root of a negative number it'll become imaginary. But for right now, if you're at this point where you're taking a square root of a negative number, you can write no solution. Does anybody have any questions before we move on? No? Okay, we're going to be doing number 5. This is going to be our last problem. All right, what am I going to do first? Number 5. Number 5. Yeah. Add 60 on both sides. So what are you left with?
Make sure you're writing with me.
Okay. Okay. Negative 40 plus 60. 20. Okay, tell me what to do next. Good. And you're left with 1. I'm going to move this up here since I don't have any more room. Now what am I going to do? Square root. And you're left with y equals what? Y equals plus or minus 1. Always remember the plus or minus. So we're working until the bell. So you can, first of all, what's our homework? Good. We're working until the bell. You can work on your homework until the bell rings. Okay? And if you have any questions, I'll come around. What?
This will be classwork tomorrow.
Oh, we're going to be doing the rest of this for classwork tomorrow.
Show them the homework. Go back.
As a workshop or as just regular?
Isn't it down here?
Yep.
I'm just
Go back. Yep. Forward. This is what you're working on right now.
Okay, so this is what we're working on quietly right now. Should I stop the timer?
Next homework on this?
Nice job today, guys. Here?